Right now, NASA is tracking 2,350 potentially hazardous asteroids. Most will miss, but some won't. These are the 5 asteroids that keep scientists awake at night. Real rocks, real threats, real dates. And for some of them, the math still isn't settled. April 13th, 2029. Mark that date. Asteroid Apophis is 375 meters wide, bigger than the Eiffel Tower. On that date, it will pass within 32,000 kilometers of Earth's surface. That's closer than our own satellites. So close that people across Europe, Africa, and Asia will see it moving across the night sky with their naked eye. No telescope, no equipment, just a rock the size of a skyscraper visibly passing through our backyard. Scientists currently say it won't hit in 2029. But here's what they don't say loudly enough. Every close pass changes an asteroid's trajectory through gravitational interaction. Each future visit requires completely new calculations. Apophis returns again in 2036, and again after that. One miscalculation, one unexpected gravitational nudge from another object, and the math changes permanently. We have until 2029 to find out exactly how close we really are to getting this wrong. 101955 Bennu, 500 meters wide, 1/3 of a mile across. NASA sent a spacecraft called OSIRIS-REx 200 million miles through space specifically to study this asteroid. They brought back samples. They landed on its surface. They studied it in detail. What they found made scientists nervous. Bennu is a rubble pile, loosely held together by gravity and rotation. It's not solid rock. It's billions of fragments from an ancient planetary collision compressed into a ball. When they fired sample collection thrusters at its surface, the ground gave way like a liquid. It nearly swallowed the spacecraft whole. The impact probability for Bennu stands at 1 in 2,700 for the year 2182. That sounds small, but scientists call it one of the most significant impact threats ever calculated for a known asteroid. If it hits, the energy released would equal 24 times the most powerful nuclear weapon ever detonated. Every simultaneously, in one impact. And we know exactly where it is. We're watching it. We just can't stop it. June 5th, 2025. An asteroid the size of an aircraft carrier will make a close pass of Earth. 2008 DG5 is between 320 and 700 meters wide. NASA has been tracking it since its discovery in 2008. It's classified as potentially hazardous. It has passed near Earth before. It will pass near Earth again. The 2025 approach brings it within 2.17 million miles. That sounds far. But in astronomical terms, that's our immediate neighborhood. If an object this size impacted Earth, it would release energy thousands of times more powerful than the Hiroshima bomb. The 1908 Tunguska event flattened 800 square miles of Siberian forest. That object was only 40 meters wide. 2008 DG5 is up to 700 meters wide, 17 times larger than Tunguska. The difference between a close pass and an impact is often measured in fractions of a degree, a fraction that changes with every orbit. Asteroid 1950D. A was discovered in 1950, then lost. Scientists couldn't track it anymore. It disappeared into the vastness of space for 50 years. Then, in the year 2000, it reappeared. And when scientists calculated its orbit, they found something alarming. 1950DA has a 1 in 300 chance of hitting Earth on March 16, 2880. That's the highest known impact probability of any asteroid for that time period. 1 in 300 sounds manageable until you understand that 1950 DA is 1.3 kilometers wide. An asteroid that size hitting Earth would trigger global firestorms, a dust cloud blocking sunlight for years, crop failures worldwide, a mass extinction event comparable to what killed the dinosaurs. And here's the part that makes scientists genuinely uncomfortable. 1950 DA is spinning so fast that normal gravity shouldn't be able to hold it together. It's held together by something scientists call cohesive forces between asteroid particles. Forces we don't fully understand yet. We don't completely understand what's holding it together, and we're supposed to deflect it if necessary. In late 2024, astronomers discovered an asteroid that briefly held the highest Earth impact probability ever recorded for an object its size. 2024 YR4, approximately 40 to 90 meters wide. For a brief, terrifying window, it showed a 3.1% chance of hitting Earth in 2032. That doesn't sound like much until you understand that 3.1% is extraordinarily high by asteroid standards. Scientists were genuinely concerned. Further observations eventually reduced the Earth impact probability. But here's what nobody talks about. The same observations increased the probability of it hitting the Moon to 4.3%. A 90-meter asteroid hitting the Moon would be visible from Earth with the naked eye. An explosion on the lunar surface seen from our backyard. A reminder that our cosmic neighborhood is not as safe as we assume. 2024 YR4 will return. The calculations will be refined again, and the number could go up as easily as it went down. 2,350 potentially hazardous asteroids currently tracked, more discovered every year, each one a calculation. Each calculation dependent on data that gets refined with every observation. We have deflection technology now. DART proved we can move an asteroid. But DART moved a 160-meter rock with years of preparation time. What happens when we find a Bennu-sized threat with 6 months warning? The answer is, we don't know. We've never had to find out. Follow for daily cosmic threats, because the next discovery might not give us time to prepare.